Alright, and welcome back. In this video, we're going to be covering a fairly common type of problem where we are modeling a periodic phenomena using a trig function, okay? So what I mean by that is that certain situations kind of resemble a sine or cosine wave curve, alright? And a lot of people get kind of stumped on these types of problems, but they're actually really not that bad. I'm going to show you how we can do one of these using a graph, just kind of thinking about it, etc., etc. So we have a Ferris wheel, right, that has a diameter of 88 feet, and it reaches a high point of 100 feet above the ground. All right. The Ferris wheel also completes one full rotation every 6 minutes. We want to write a function that models the motion of the Ferris wheel starting at its low point. All right. Now, that can seem fairly daunting, but let's go ahead and sketch a picture, and do not make fun of how terrible I am at drawing. All right. So I'm going to go ahead and draw a Ferris wheel. There's my Ferris wheel. Okay. Now I know that its diameter, I know that this diameter is 88 feet. Okay, so also think about what that kind of means for the radius. If the diameter is 88 feet, that means that the radius must be 44 feet. So I know it's 44 feet from the center to its maximum and to its minimum. Okay, now think about what that means. That's our midline. It's going 44 above and 44 below. So right away, that actually tells us something. I know that we're going 44 feet above the middle of the Ferris wheel and 44 feet below the middle of the Ferris wheel to hit our max and min. So that actually tells us what our amplitude is. The amplitude is 44 feet, and I'll kind of show that in a graph as well. I'll go ahead and graph the situation. We could do it that way as well. Another thing I know is that from the low point, so I'm going to say this is the ground. I think that's how Ferris wheels look, whatever. From the ground to the high points, so from the ground to the high point is 100 feet above the ground. So I know that it has a max of 100 feet. What I don't know is what the minimum is. Okay, but I can quickly figure that out. If I think about this, well, this total distance here is 88 feet, and the full distance is 100 feet, which tells us this little distance here must be 12 feet. So the minimum is 12 feet. Okay, that's from 12 to 100 is 88 feet, and that's the diameter of our Ferris wheel. Okay, so I already know quite a bit of information about this. I know that the maximum is 100. I know that the minimum is 12 feet. I now know that the amplitude is 44 feet, which is actually the radius of this Ferris wheel, which is actually kind of always going to be the case for these types of like Ferris wheel type problems, which are very common. Okay, the radius is going to end up being our amplitude. All right, what we don't know is what the midline is. What we don't know is what the midline is, but we can kind of quickly figure that out. If we think about the value that's right in between our max and min, or I can just go 44 below our max or 44 above our min, that would end up giving me that this distance right here, this midline, is 56 feet. If I do 100, this is 100 minus 44, I get 56. If I do 12 plus 44, I get 56. So our midline is y equals 56, and I guess I'll say feet. So the center of the Ferris wheel is 56 feet above the ground. So that actually gives us a lot of information. So I'm actually going to go ahead and start kind of sketching a curve so you guys can see what I'm talking about using a graph. So let's say this is my scale, okay? I'm not gonna like do like a conventional scale, just so you guys know. So the midline is 56. The minimum is 12. The maximum is 100. I start down at the minimum. It's telling me that. and then I start some of the rotation, and I end up right at the midline. I don't know what that point is, but we'll find out in a second. One thing that we haven't talked about yet is this 6 minutes. Okay, we'll get to that in just a second. Then some more time goes by, and I end up at the maximum. Okay, then some more time goes by, and I end up back at the midline. Then some more time goes by, and I end up at the minimum. So our graph kind of looks something like this. And what this should be telling you is that we're starting at the minimum. We'll think about what type of function does that. Cosine starts at its maximum, but a reflected cosine starts at the minimum. So we know that this is a reflected cosine graph. Now you technically could make it a cosine graph that's not reflected using something called a phase shift. You can also make this a sine function using a phase shift, but that's actually a little bit more complicated. So I'm going to go ahead and make it as simple as possible. So we're going to use a reflected cosine function. Reflected cosine. I forgot to write cosine. Okay. Now the only thing that I now need to figure out is, well, what are these times? Well, it's telling me it takes 6 full minutes to do a full rotation. Okay. So if it's truly periodic and it's going at a constant rate, okay, it's rotating at a constant rate, and it takes 6 full minutes to do a rotation, that means it must take 3 minutes to do half a rotation, which means that it must take 1.5 minutes to do a quarter rotation. So you can write this as 1.5 or 3 halves. You can write this as 4.5. You can write as 9 halves, whatever. Okay, but there is our scale. The last thing we need to think about is, what is the period? Well, they actually tell you what the period is. It's 6 minutes. It takes 6 full minutes to do a rotation. So we actually have all the information, or most of the information we need to write a function. We're going to make this a reflected cosine. Well, the amplitude is 44. Now, I'm not putting a 6 in here. I'll get back to that in a second, because that's what we did not talk about just yet. But I know the midline is 56, and I know since it starts at its minimum, it's reflected. If it started at its maximum, we would not have the reflection, okay? If it started at the midline, that would actually be a sine function. So you got to think about if it's sine or cosine dependent upon where it starts. If it starts at the midline, remember that's sine. If it starts at the max or min, remember that is cosine. Now the reason I didn't put anything here is because that's the value of b. And b normally helps us find the period, but we actually already know what the period is. So we got to figure out how we find that b value out. Well, remember, to find a period, we do 2 pi over the absolute value of b. Well, I know what the period is. It's equal to 6, so I can set 2 pi over b is equal to 6, and now I can go ahead and solve. So I'm going to go ahead and get 2 pi is equal to 6b, which means b is equal to 2 pi over 6, divide each side by 6, which gives me the reduced value of pi over 3, okay, which gives us our function of y equals negative 44 cosine of pi over 3x plus 56. And this is the function that models this periodic phenomena, okay? So make sure that you really kind of analyze this and see where all of these values came from, all right? Because it's actually not that complicated. It's a little tricky at first. The first time you do this, you're probably completely confused. But once you try a couple of these, everything kind of falls into place. So that's how we can use a trig function to model a periodic situation. I hope this helped you, okay? So make sure you practice this. You'll definitely see problems like this, probably on like an SAT or ACT, probably one of the harder ones, but you might see it, okay? So make sure you're practicing, and goodbye.